Okay, it sounds like I'm here, so go ahead. Yeah, awesome. Thanks everyone for coming. I know it's late in the day, and also I have a weird talk title. I am presenting on this, basically everything I've been thinking about for the past couple years, basically all through COVID, and it's called Paradigm Lost. Very ambitious talk. Don't bother taking any notes. I've already published all the talk notes on my site. So you can look at all the references and all the links that I'm about to drop later on if you wish. My goal with this talk today is to raise your ambitions. Actually, if I do this right, someone in this room is going to change their career based on something that they learned from here. That's what I'm trying to do. I'm trying to really break the mold and expose you to something that you may not have thought about or taken seriously up till now. The reason I have this kind of goal or ambition is because it changed my career. And that's something that I think just makes talks worthwhile. Like it tells you something that, or exposes you to something that you may not necessarily have known before. Okay, so, and I kind of start with this, which is a little bit spicy, which is the state of JavaScript versus where we are in the Stack Overflow salary rankings. Most people report being happy with the general state of JavaScript, but then if you look at the Stack Overflow salary rankings, I actually kind of, the visual effect is kind of lost here. When I look at like the Stack Overflow salary rankings, I kind of scroll down and I go like, all right, where's the JavaScript people? All the way down here, and then front end's all the way down here. And I'm just like, like there's something going on here. There's something that is not being fully told. I just don't really know what it is. Like fundamentally, when I changed careers, way back when, like I was told that this was the way to learn the code, and I got into JavaScript, and I realized like there's something that is still missing in the way that we conceptualize what full stack really means. This is one of my most ambitious talks, where I'm actually going to present 6 talks. So sincere apologies to whoever's annotating the talk, but I'm going to try to give you structure so that you can follow along. It's really just like really small micro talks, and we're going to try to trace the paradigm shifts that I think have been super interesting and I've been obsessed by. So one, we're going to talk about the standard paradigms, and then we'll talk about comparing that with the reality, theory versus practice, and then the 4 paradigms that I've been focusing on recently. And the whole talk is based around what does it mean to be full stack. I've been really kind of thinking about this word and thinking about what stacks really mean. There are a few conceptualizations of that. So, so that's part 1 of this talk, which is what the standard full stack paradigm is. I kind of relate that to the standard model of physics, which is kind of the accepted way that we understand how the world works today. We also know that it is incomplete, but it does work well enough. So similarly, the standard paradigm of full stack dev, we know it's kind of incomplete, but it works well enough to get people into the industry. And I think this is probably the most popular meme of how people conceptualize what full stack is. There's a front end, and then there's a bunch of technologies in the front end. There's a back end, there's a bunch of technologies in the back end. Learn both, you're full stack. It's reductively simple. I kind of think of this meme. There's a book, What They Teach You at Harvard Business School, and then there's another book, What They Don't Teach You. Put them together, you know everything. The name, front and back, what else is there, right? You go front, you go back. You could be a little bit heavy in the front. You could be heavy in the back. I know Tejas likes this meme. But fundamentally, we're all kind of, if you want to be full stack, JavaScript runs everywhere. We think of ourselves as full stack if we do the front and the back end. There's other conceptualizations of this, especially developing over time as we grow in terms of our technology. There's lamp stack, mean stack, jam stack. You're probably all familiar with this. I'm not going to belabor the point. There's another framing of this, the 3-tier architecture, which is more sort of enterprisey, but it's fundamentally the same thing: client-server database, client-server database. Personally, I like to think about things in terms of layers. I'm very inspired by the OSI layer model. So I tried to create, from a book, an OSI layer model for the coding industry. Everyone who writes software, from firmware all the way up to low-code and no-code people, they're writing software still, just different kinds of software. But still, I don't think this is enough. I think the separation this is the standard paradigm, and I think it's breaking in very interesting ways, and that's what I'm presenting to you here today. So what is reality? I had a very interesting audience participation segment here, but I'm going to skip it in the interest of time. Just trust me that you can look this up later if you want. Jason Miller from Google actually wrote this amazing blog post called Application Holotypes, where he just went through and thought about what are the different types of apps and what kind of different technologies do we need per each app. And he kind of listed out these, I think it was like 11 or 12 categories. I left some of those out. But anyway, I thought it was just like a really interesting way to model it. Another collaborator of mine, Arthur Wu, actually did a little flow chart. So if you're thinking about what kind of apps you want to make, you can sort of work backwards into what kind of features are required and therefore what technology choices you should make. And I think some of these are very interesting. I won't go into detail on all of those, but I really encourage you to check these out because these are fundamental theories of how we design and choose technologies. So I'm going to start going to like very specific questions, because I think for me, part of the reason I learned to code was to do whatever I wanted to do, like to go from thought to final product in as quick a way as possible. On the left is archive, which is basically the most open way to submit academic journals. It's a very simple submission list, and it's not very easy to browse, not super user-friendly. So Andrej Karpathy, recently from Tesla, created Archive Sanity, which added a few features. And the few features that he added were just such an amazing UX improvement. You get comments like Archive Sanity is a lifesaver because you can keep track of recent papers, search for papers, sort by similarity, add papers to a personal library, get personalized recommendation. In other words, it turned a site or a repository into a full app. And I just think it should be easy for us to do this. And if it's not easy, then we're not good enough yet, or our technology is not good enough yet. We need to force technology to serve us, to create UX like that. And it's probably not going to be served by another front-end framework. This is a fundamentally different paradigm. Generalizing just from the Archive Sanity example, here's a non-exhaustive list of stuff that you would want out of basically any application. I'm not going to belabor the point. Again, you can refer to my notes for the full list. But I just think the amount of features that are informed by data, machine learning, all that good stuff, it's just so much more than we typically talk about in a typical paradigm that we think about when we think about full stack. Another example, I love picking examples from Hacker News because they give you points to show which one is more worth paying attention to. This one got over 1,000 points, and it's basically a book recommendation app. I'll just click this and hope the internet works. Someone tossed me a search term, what kind of book are you looking for? Fiction, nonfiction? Growth hacking. That's a fantastic word, fantastic term. No matching books, but we can probably yeah, I'll just say growth. That's kind of the industry shorthand for that. A lot of managers path, but then it's just so useful. It's just fundamentally so useful to see to be able to search, to see metadata, to see genuine commentary about about a certain thing. I just love this kind of application, and everything that I've been taught my entire tech career has not enabled me to build this. And so I'm kind of furious. I'm why isn't this easier? I don't have a solution for you. I'm just this is a level of ability that I don't have, and I spent this long in tech, and I don't have this. Shazam just turned 20, so started in 2002, and we still cannot build this. Shazam, this guy's saying Shazam is one of the very few apps in the past 20 years that still wows me. How do we build that? It's just such an amazing way. By the way, there's a audio search algorithm published that goes into that. I'm not saying everyone should know how to do audio search, but I just think it's super interesting that you can call yourself full stack, but never really push yourself to build search algorithms or anything like that. So to me, those are the kinds of paradigm shifts that I'm looking for that really wow people and turn something from impossible to normal. So we're going to go into the 4 paradigm shifts, and these are sort of rapid-fire lightning talks. I don't know. So the first is local first. We'll talk about the evolution of the local paradigm. I'm going to take a random demo. This is not really anything to do with the demo itself, but this is the state of the client-server paradigm as it is today, right? So I'm going to enter in some stuff. I'm going to hit enter, and then there's a little bit of a lag, right? And especially if I hit delete on a bunch of things, like the UX is not super responsive. We all know why this is the case. It takes some time for the network request to cross the wire. So in order to turn this, make this faster, like it's always the network request, right? Like the speed of light, speed of light, TCP handshake, whatever is causing the latency. In order to actually keep people in flow and actually provide a good user experience, we need to speed that up to have a local database. And the fact that it's not normal in most apps kind of is a problem. The way that we solve it in sort of increasingly powerful technology, first, talk about PWAs a lot. Then we build entire apps in C++ or whatever and compile it to WebAssembly. I think the two most interesting movements in the sort of local first mindset are moving the backend closer to the user. So you don't have to go so far in terms of the network. Edge functions, I think, are pretty much a hit. Here's Ryan Dahl at the recent Remix Conf talking about his dream stack and how Dino is going to be edge first. And I think pretty much everyone, like the secret is out, and most frameworks are going to rewrite themselves to be rendering edge first as much as possible. There's no more pushing to US East 1. The availability zone is instantly global everywhere. I think this is the norm, and there's not much open for debate these days. The one that is more open for debate is the embedded database. A lot of people, especially when I was learning JavaScript and React and Redux, you would write your Redux store, Apollo store, your reducers or resolvers, write the endpoint, write optimistic updates, persist them, roll back errors, do conflict resolutions, or you could just get it off the shelf. And I just realized there's just so much work that is involved in there that you're basically writing a database with a journal and rollbacks. Like you might as well pick a well-rolled paradigm. There's some obviously more mature solutions. The one that really opened my eyes was Minimongo from Meteor, which I think still holds some favor in my mind. I actually used to work at AWS, where AppSync Data Store was the equivalent of that. Basically, you're cloning a remote version of the GraphQL database that AWS provides you into your local device, and I thought that was super interesting. But both are kind of proprietary formats, and what you really want, what people are really experimenting with, are open source databases like SQLite embedded in a browser, or DuckDB, which is the analytical version of SQLite. I highly recommend you checking out all these blog posts. I just don't have time to go into them, but they give you an idea of how responsive and fast some of these apps that are built local first can be. So local first paradigm gives you no spinners, works offline, seamless collaboration, all that good stuff. I think this is one of those things that I really would like people to work on and maybe sort of establish as the norm. So the second thing that I worked on is async. And I kind of categorize this as like a whole paradigm. It's really weird to call async a paradigm because it kind of is. We took so long to go from callbacks to async await. This is callback hell in Node.js. And every time I have a thing up like that, I'm obligated to provide a Hadouken in the callback pyramid of doom. But obviously, having the async await syntax collapse all of that, so we're more easily able to move code around. It's not entangled unless you really have to entangle it with scope. What is the equivalent for that? Like we'll talk about that in terms of infrastructure, but I like to think about this so much because I think software becomes so much more valuable when you move from sync to async. Really, software is sort of commanding the machine to do stuff without us present. And I think the simplest example is one-click buy. Here's Joe Spolsky, the creator of Stack Overflow, talking about it. You can look it up on YouTube. But essentially, one-click buy, what one-click buy solved was that there was 70% cart abandonment. So instead of going from cart to checkout, you could just click a one-click checkout with and offer people an undo with 30-second timeout. But in order to do that, you have to do all this engineering and infrastructure, right? You have to persist it server-side, because otherwise, if the person closes their browser, then you'll have lost the order. And if there's a temporary API failure, you need to retry it. So there's a lot of these like little nuances and reliability issues that rise up when you move from a synchronous paradigm, which is like, one-click check out the cart and then going to the cart and checking out to payment, and you moving that to an asynchronous environment where you set timers and do stuff without human supervision. And another reason why async is hard, I think when people think about timers and schedulers and job runners and job queues, they're like, there's so many cron jobs available. I can just set things on a cron and power my asynchronous jobs based on that. So that's what I did with GitHub Actions, only to realize that GitHub Actions fails a lot. This is a live log of, I set it to run every couple hours, and here's a live log of every single failure in GitHub Actions over the past couple weeks. It fails a lot, and probably you won't have any time. Thanks. You won't have any time to write the retry logic or to store any of the state of what you're doing in GitHub Actions. So there's a lot of async tooling out there. Probably the most famous in my mind is Sidekick from the Rails ecosystem, but JavaScript has a couple as well, and some people roll their own through queues and caches. And I think in the AWS world, like we're so used to doing this. Like we're setting up like 3 queues and 1 AWS Lambda just to set up 1 dead letter queue for retrying. But that's just for 1 asynchronous call. If you do this for every asynchronous call, you end up with this kind of architecture, which is a real madness. Like, and nobody really wants to do this, and therefore it actually slows down your application. Like again, like we're trying to provide better user experience by providing an easy move to async. So what I ended up finding and learning in my journey was that the solution to this is called orchestration, right? Moving from a choreographed world where you sort of plan everything out in infrastructure to moving towards like a software-defined version of that. The best solution I found was the company I ended up working at it's called Temporal, where you centralize all that timing and state logic. And I've done a separate talk at React Miami if you want to follow through on that, but you can implement one-click buy very easily. And in reality, the whole reason I'm interested in this is because real-world user experience requirements kind of look like this. You want to send an email, you want to wait for something to happen. If the user cancels, you want to respond to it, and then you want to proceed on to different stages of a user journey. And you want to model that simultaneously running for thousands of millions of users. Imagine if you could do all of that in a single function. That's what we're trying to go for. It's also surprisingly ubiquitous. Like all these companies use it. And when I did an interview with Will Larson from Calm.com, he was like, "Yeah, like most companies take a long time to figure this out. How did you figure this out so quickly?" And I'm like, "Why did no one tell us that this is a well-known thing in top-tier startups until, I guess I showed up in the right place at the right time." And finally, it's becoming a career. So to me, this is one of those paradigm shifts that is pretty mature and about to cross the chasm into well-known popularity. So I just want to wake you up on that, that it is becoming asynchronous is a huge opportunity. Second to last, data. Data is really big. I consider this the data blind spot of web developers. Here's the job trends, the search trends for front-end developer, back-end developer, full-stack developer. Obviously, a lot of demand for developers in recent years until you compare it to data engineer. Let's search. And that green thing just puts everything else in comparison. Let's talk about data analyst. Of course, much higher. Why so much? Is it just a meme? Well, there's just so much data that we're accumulating in our systems, and we don't know how to process it. Both structured data and unstructured data, just to give you an idea of the magnitude of growth, that's a 5x growth in 3 years. Data is a moat for most companies, and understanding how to manage that data is important. And just so you don't think it's just a purely capitalist thing, I think it's also UX. There's so much spam that, this is a screenshot of my DMs. Every time I get a spam DM from a CryptoBot, I hit spam and I try to tell Twitter to block it, but they never do because they don't know what to do with that data. It's just sitting there unused. So we would be able to improve the UX if we know how to make use of data. And if you look at the application holotypes that we introduced earlier, like some significant percentage of these are actually data-intensive applications, and we're not really well trained or set up to learn these unless we work there. And it's kind of a problem to me because all of these are also the most valuable companies in this data set. So I just want to wake people up to like how we are typically sold the idea of full stack as client server and doing some basic CRUD, but data-intensive applications are a whole different animal. And in fact, there's first-party data, there's post-process data, there's third-party data. Like there's just so much there beneath the iceberg that I just think we should all explore it a little bit more. It's quite disruptive in terms of our paradigms. Another paradigm, we're very used to saying that JavaScript is the most popular language. Not so true by two measures. One, Hacker News job postings. Two, the TOB index of languages. If you look back at the salary rankings, I marked out the stuff in green that is typically JavaScript and the stuff in red that is typically data. It is moving. You can see it. You can see data moving up in data terms. And then one of my favorite charts, the number of companies in Y Combinator going up as more people invested in managing data for you. So I think it's just a very interesting element. Like there are a lot of startups. Is that 5? Thanks. There are a lot of startups that are interested in managing this, and I think people have the lingo, but they don't have the skills. And this is one of my favorite jokes. Like the number of times I've been asked to A/B test something, and I just don't have the technology or the skills or the people or the traffic, to be honest. So A/B test anything, I think, is a real problem. The first thing that most people should know is that data science, like a lot of people jump straight to data science, but you should probably work on data engineering first. And that's where I've been mostly. Most people, like, you want to make an MVP of a product, you want to add analytics to that, and then typically the behavior is you add a feature and then you look at the analytics. But you also want to look at it the other way by studying analytics first and then creating a feature to suit that. The biggest success story of this sort of inverse operation probably is the app Bourbon, where they tried to do a whole bunch of features and then they realized that people were only using one of those features, and that was Instagram. For anyone interested in building a startup with a data-driven sort of mindset, I highly recommend this article by Crystal Wijaja. And primarily, I want to introduce, for those who are like very new to this space, introduce the idea of extract, transform, and load. I particularly work in the space of ELT, the inverse of that. Don't have time to explain that. But I think like the whole data engineering paradigm is just so massive and deep that I just think it's like, it is something that you should start keeping tabs of if you've been completely ignorant of it. Okay, last piece, AI. This is the fun part. I had to squeeze it in there. Software 2.0 is essentially what Andre Karpathy has been trying to push as like sort of the successor to deterministic software. I think very interesting. In my mind, like going from deterministic code where we write the code to machine learning where we provide the data sets and the code forms itself. Mostly people think about the exciting versions of this, computer vision, self-driving, but really the bread and butter stuff is actually the stuff that is being commercialized. It's so much so that it's boring and people don't even consider it when they think about machine learning. For anyone who's interested in this domain, I highly recommend checking out Applying ML from Eugene Yen. He's just a really good curator of this space. But software 2.0 going to 3.0 has been a huge shift. I don't need to introduce any of these terms to you, but I just love talking about the size and scale of this thing, right? Like here are the increasing sizes of the models that are being involved. The y-axis is a log scale, so I just had to put it on a regular scale just to show you the exponential improvement or the exponential increase in scope. I love also showing off the translation models because I think a lot of us think of it as cute, as something that's constrained to art, but it starts getting very serious very quickly. So here it's translating English to Spanish. That's very cute. Google Translate has been doing that forever. But then your smile starts to disappear when it starts to do SQL for you. And when you can say what % of users who signed up converted to paid, and it outputs valid SQL, that starts to be concerning, or positive, depending on how much time you want to spend writing SQL. It starts to explain jokes. They understand jokes now. It is so bizarre, like how much can be done without us, and how much they now comprehend what we want. Obviously, everyone's familiar with GitHub Copilot, but maybe less familiar with that. They're actually producing competition-level code with Alpha Code. I'm going to skip a little bit. Yeah, I'm going to skip a little bit of all this sort of image generation stuff. I assume you're familiar with it. What I really want to focus on is the ability to take a really crappy first version, add a prompt, and then come and output a really great version. This prompt is a field that is developing. Let me just skip to what is being called prompt engineering. I think in part it's kind of an analogy, but also it's probably going to be pretty serious. So we went from designing the algorithm to designing the data set to now designing a prompt for the large language model that we have. It is not a joke. I think people might think that prompt engineering might be an analogy, but they have some serious. Oh God. Okay, I screwed up one of the slides. Without a good prompt, they have some benchmarks where the accuracy is 17.7. With a really good, with like a 5-word prompt, they've increased the accuracy to 78.7. And that's what has these like machine learning researchers like all in a fluff, because like this is way too easy. This is it's really going to be a career. Like basically, people are learning how to do this. They're publishing books based on this. There's marketplaces sharing the best prompts. This will be a job for people because it's so disruptive to create these prompts for applying to the right use cases. There's lots of ethical issues, of course. There's the carbon footprint involved in training these models. There's competitions that you might have seen today, where people are winning competitions that are meant for humans. And there's people that are sort of washing themselves from responsibility when they create these languages, problematic languages. But I just want to remind people of the exponential progress that we're seeing. This is the state of the art in 2014, and this is the state of the art today. And it's really shocking how much there is to go. And I think that the paradigm shift that is involved here is happening right as we speak. And I think it's worth paying attention and honestly just trying it out. So that's the evolution of software so far, that we're going from writing code in machine languages like JavaScript or Python to writing prompts for a model to understand. And that's something that's just fascinating to me. So we're almost done. What does it mean to be full stack? I'm sort of bringing it back all the way to the beginning. To me, it's really like there's just so many paradigms to choose from that I just think this is my collection of acronyms: PWA, MVC, CRUD, orchestration, ETL, DSML prompts. Once you do that, you're full stack. I do think that these are the main paradigms which I think have the most potential business-wise and in terms of the potential to change humanity. So paradigms are found. Thank you.